Assalamu alaikum, everyone. Today we'll be having our first class on further statistics. Today I will start with the lecture of this chapter, continuous random variable. Today on this topic we'll be having our lecture 1. For continuous random variables, the first topic we'll study is the further probability density function. Here we'll have 4 segments basically. First of all, we'll be having a reminder on continuous random variables, and then probability density functions defined piecewise, and then expectation of a function of a continuous random variable, and then linear functions of a continuous random variable. So for reminder, continuous random variables, actually you met continuous random variable in probability and statistics 2, in S2. A random variable is a set of outcomes for an experiment or even. A random variable is continuous when the set of outcomes is continuous. Examples of continuous random variables are the weight of a newborn baby, the lifetime of a light bulb, and the time taken to swim a length of a swimming pool. These are the examples. A continuous random variable is described by a probability density function. In short, we say PDF. Probability density function. The graph here shows an example of a probability density function for a continuous random variable. Here you can see a graph here. So a probability density function like the one shown above may be found from the results of an experiment, or it may be given as an algebraic expression. This curve, I'm talking about this curve, it may be availed by experiment or by the function. The total area under the curve of the probability density function must be 1. You can think of this area as being the sum of the areas of infinitesimally thin bars like this. If the PDF is given by an algebraic expression, you can calculate this area by integration. Now, you can find the probability of a particular range of outcomes by finding the area under the graph of a probability density function for the range of the values. If the probability density function is given by an algebraic expression, you can do this by integration. Now, here, the next topic, I talked about the 4 segments here in further probability density function. Next segment is probability density function defined piecewise. So you met this in S2. I hope all of you have covered S2 before starting this class. You should do that. So this is a piecewise function. Sometimes probability density function follows a different function for different values of x, like a piecewise function. I think you are familiar with this thing, that this is an example of a piecewise function. If the x ranges from 1 to 2, it follows this function. If the x ranges from 2 to 4, it follows this function, or it follows 0 if otherwise, if the values of x is not within these ranges. Now, they're asked you to find, we'll solve this sum now for you. Here, you are asked to find the values of a and b, and we know that, now I will solve it for you. We know that the total probability must be 1. The total probability must be 1. So if I integrate all of this, that would be equal to 1. Now, if I write integration of ax squared in the interval 1 to 2, plus if I integrate the second function bx, that would be equal to 1. Now, a is a constant, so take it outside, and then integrate this 1/3 x cubed, 1 to 2. B is a constant as well. Now, this one is x squared by 2, 2 to 4. This is equal to 1. Now, if I put the values here, we get 8 by 3 minus 1 by 3 plus b times 8 minus 2, that is equal to 1. Now, if I use the calculator, I think you will get this 7 by 3a plus 6b is equal to 1. If I multiply with 3, the whole equation, if I multiply the whole equation by 3, I get 7a plus 6b is equal to, 7a plus 18b is equal to 3. Now, we can also say that the PDF has two different definitions, has two different definitions for x is equal to 2. For x is equal to 2. So these two must be equal. Like what I meant to say that you can see that this function is defined for x is equal to 2, and this function is also defined for x is equal to 2. So if I put x is equal to 2 here, if I put x is equal to 2 here, this 2 should be equal. So we can write like this. If we put a in the 2 in the first function, we get this. If we put a in 2 in the second function, we get this. These two are equal. So we can write 2a is equal to b. So this is equation number 1. This is equation number 2. Now from 1, what we get? 7a plus 18 into 2a is equal to 1. That means a is equal to 1 by 43. So b should be equal to 2a. That means 2 by 43. So these are the values of a and b. I hope you have understood this, guys. Number 2, find probability of x less or equal to 3. We know that to find a certain probability, you have to integrate. Now you can see that x less or equal to 3 includes this whole range and a portion of this range. So we should write like this. For part 2, we should write like this. Probability of x less or equal to 3, it should be equal to 1 to 2, 1 by 43, the first function, x squared dx, plus 2 to 3, because you are asked to find probability up to 3. So this one is the second function, 2 by 43 x dx. Now you just simply integrate this. So what we get, 1 by 43 into 3, 129 x cubed, 1 to 2 plus 1 by 43 x squared, 2 to 3. So if I put the values here, 1 by 129, 8 minus 1, plus 1 by 43, 9 minus 4. 22 by 129. That's it. So this is all about the types of sums here, that the topic, the probability density function defined piecewise. Now we'll move to the next topic, guys. Expectation of a function of a continuous random variable. Please take some time, pause the video and write down the notes here. In S2, you saw that you can find the expectation of a continuous random variable by integration, this one. Sometimes you may need to work with the function of a random variable. For example, suppose you have a continuous random variable x that is defined by a probability density function and another continuous random variable y that is defined by this. You can find the expectation of any function of x, that is gx, by integration. That means e of gx, integration of gx fx dx. And similarly, for variance, you can find the variance of any function of x in this way. So please note it down, guys. We'll move to a sum after you have completed writing these notes, guys. You see, these are all connected with S2. So for doing further statistics, you must remember that you must complete probability of an statistics 1, that is S1, and probability and statistics 2, that is S2. Without completing those 2 units, things would become very difficult to understand here in further statistics. So don't be in a hurry, guys. First, finish those 2 units and then start doing the further statistics. Otherwise, you'll be in trouble. Now, you can look at this sum. If we read the sum, what we get here, a random variable y is has a probability distribution function fx that is written in this way. Find the expectation and variance of y, find the expectation and variance of 2y minus 1. Then we'll be moving to the part 3 and 4 later. First of all, let us do part 1 and 2. So from the concept of S2, we know that E of y should be equal to integration of y times fy. That's it. We know this. So if we integrate this, then we'll get like this. Y squared minus y dy. Now if we integrate now, 1/3 y cubed minus half y squared, 1 to 3. So if I put the values here, 27 by 3 minus 9 by 2. And then if we put 1, we get minus 1 by 3 plus half. Now use your calculator, guys, and I think you will get this value. So this is the expectation for y here. Now, if I move to variance of y, we know that variance of y is actually e of y squared minus e of y whole squared. So e of y squared would be integration of y squared times fy. Y squared times the fy. Now, if we rearrange this, y cubed minus y squared dy. So we'll get half 1 by 4 y to the power 4 minus 1 by 3 y cubed 1 to 3 minus e of y whole squared 7 by 3 whole squared. So if I put the values now, first of all 3, then I'll get 81 by 4 minus 27 by 3. If I put 1, minus 1 by 4 plus 1 by 3. Now, minus 7 by 3 whole squared. Now, if you use your calculator, I think you will get this value 2 by 9. So part 1 and 2 is done. Now they are saying that a cubic box has a side length x centimeter, where x is a random value from a distribution whose PDF is the function of f defined above. So the PDF of this one is a function of this. Find the expectation and expectation of the volume V of the box. So now we'll move into the expectation of the topic is expectation of a function of a CRV, of a random variable. So now V is a function of the random variable here. So how to do that? Let us go into that. First, oh, sorry, I missed the part 2. Sorry, guys. This is not part 2. So I have to do part 2 first. Find the expectation variance of 2y minus 1. We know that E of 2y minus 1, it would be 2EY. We learned this in S2, minus 1. So now you put the values, 2 into 7 by 3 minus 1. That gives you 11 by 3. Now, var of 2y minus 1, it would be 2 squared var 1. So that means 4 into 2 by 9, we get 8 by 9. That is part 2. Now we can move to part 3. You are asked to find E of V. So as this is a cube, V can be defined as x cubed. So I have to find E of x cubed. And you know that E of x cubed should be integration of half x cubed into the fx. X cubed into the fx. Fx is half into x minus 1. As you know that in S2 you learned E of x to the power n is integration of x to the power n fx. So here limit should be 1 to 3. Half, if we expand this, we get x to the power 4 minus x cubed dx. Now, if I integrate 1 by 5 x to the power 5 minus 1 by 4 x to the power 4. 1, 2, 3. So half 2, now you put the values 243 by 5 minus 81 by 4. Now you put 1 minus 1 by 5 plus 1 by 4. Now use your calculator to get the value. I think you will get 14.2 here. It should be 14.2. Now let us move to part 3. They asked for, the question is find the probability that the volume of the box is less than 8. So that means we need to find part 4. We need to find probability of a V less than 8. V less than 8 means probability of x cubed less than 8. If probability of x cubed less than 8, if we do cube root, that means x less than 2. X less than 2 means I have to integrate between 1 and 2, this function. So it would be, that means you have, you'll be having integration of 1 to 2 of the function fx only. Because we know if we integrate the probability density function, we get the probability. So it's not about the EX or VARX, guys. Remember, this is probability. And if we integrate a PDF, we get probability. Simply integrate the PDF here. So if we integrate now, we get this. And now we put the values 2 minus 2 minus half plus 1. Now, if you put these values, we'll get, in your calculator, we'll get 1 by 4. So that is your answer. So this is the end of the summarize. You have to please write down a note. Notice in this example, how part 2 can be done by using the standard results. By using the standard results. But part 3 deals with a nonlinear function of x. So has to be done from first principles of first principles by integration. Please write down the notes, guys. Now, we can finish our lecture by discussing this point. This is the fourth segment. As you can remember, I talked about the four segments that we'll study here. These four segments. This one, just some notes that it will be enough for you. In case of gx is linear function in the form ax plus b, these results become this. Just look at this. Look at the steps. You can easily understand that. Okay. Now, this result is really just common sense. If you have a set of data with mean k and you add b to each item of the data, then the mean of the new set of data is k plus b. Similarly, if you multiply each item by data by a, then the mean of the new set of data is ak. So this one plus b. Now come to the variance. You can look at the steps here, how I did it. So just follow this thing and please note it down. When you will be writing, it would be very, very clear to you guys. This result is also a common sense. If a set of data is all multiplied by a, then it becomes a times as it's spread out as before. So the standard deviation is a times the original standard deviation. Hence, the variance is a squared times the original variance. Adding a constant does not change how much the data are spread out. That means variance is not affected by plus or minus. It is only affected by multiplication or division. These results can be useful. However, remember that they apply only to cases where gx is a linear function. You have already had to calculate e of x squared to find the variance of a random variable. So you know that e of x squared is not equal to e of x whole squared. However, it is the case e of ax squared is equal to a e of x squared, as this is a linear function of x squared. Please note down these things, guys. Very important. Please note down. Now, guys, these are some exercises. I have segmented this exercise in two levels. First of all, this is exercise level 1, and this is exercise level 2. In exercise level 2, you will be having total 6 sums. So you have to finish these two exercises, two worksheets, and I will share the answers of these worksheets in our next lecture, inshallah. Thank you very much, everyone. Take care. Assalamu alaikum.